Hey everybody, it's day 4 homework time. You can see on the paper that I'll be writing on, I've already filled in my parent graphs. Today we focus on 2 different parents because hopefully we're getting the hang of this a little bit better. We're focusing on the square root parents for the first few on page 7, and then on the last 4 we're focusing on the x cubed parent or cubic. So take a minute, pause me, fill in your parent graphs for those 8 functions, and then I'm going to go through and talk about what I'm hoping, the connections I'm hoping you've made by the time you've graphed a bunch of these in your Inspire. If you haven't yet, it's okay, but you want to start thinking about it and start getting there. So I'm not going to be flipping back and forth between Inspire pages. I'm going to be making the connections about the equations of the graphs and what that part of an equation does to the parent graph. So here we go. Starting with those 4 square root parents, we'll go to number 1. I have a square root of x minus 6. What I hope you've noticed with your sliders and everything is that anytime you have a plus or minus at the end of your equation, we call that k, that translates your graph up or down. So in this case, I'm going to move my parent graph down 6 units. So I take each point on my parent graph and move it down 6 units, starting usually with the anchor. And you can start to see this -6 is in the equation of the new vertex or anchor point. And the pattern continues from there. Let's see. Okay. Now what you might have noticed I just did is I counted over from my anchor point to get to my other points, because with translations, shapes and sizes don't change. You certainly could have taken each point on your parent and counted down 6 units. It does the same thing. Okay. Number 2, here I have the square root parent of x, but a plus 8 within parentheses. And this can get a little tricky. What this really means is the square root of x minus a -8. And this, I think, is one of the most important things you can see when you do those sliders. When we moved any graph with the sliders on your Inspire 8 units left, it made it a plus 8 in parentheses. And it's because the general form of whatever your parent is x minus your h movement. So I'm moving -8, but when I subtract a negative, it becomes positive, because we're big kids and we don't double sign anymore. So this is one of the trickier pieces, but you'll start to get the hang of it. So I'm going to take this parent graph and I'm going to move all my points left 8 units. So I'm going to come over here, and my new anchor point is -8, 0. And again, translations don't change shape or size, so I'm going to just go over 1 up 1 as if it's the square root of 1, over 1, 2, 3, 4 up 2 as if it's the square root of 4, and 5, 6, 7, 8, 9, 1, 2, 3, as if it's the square root of 9 to get me 3. There's my child. Again, you could have taken each point on your parent and moved it left 8. Gives the same result. Just want to show you a bunch of different ways to do it. Okay, number 3. We saw that anytime we have a negative a out front, that's a reflection over the x-axis. So I'm just going to take all my points on my parent and reflect over the x-axis, which means go the same distance to the opposite side. And you've seen that for years and years with parabolas. We start out talking about parabolas and how sad parabolas are negative and happy parabolas are positive. And again, it all comes back to math is consistent. All right, number 4, 3 times the square root of x. We saw that when a is a bigger number, this is a dilation. So what's happening is this is going to be dilated by a factor of 3, which means I'm going to be vertically stretching away from x. And the way I figured it out is to multiply by 3. Okay. Here's one of the important pieces of having an anchor point. 0 is a distance of 0 from the x-axis, and 0 times 3 stays 0. When we dilate, we need a center of dilation, and then everything stretches or shrinks from there. So that center of 0, 0 stays put. Your anchor point stays put with a dilation, and everything else stretches or shrinks from there. So over here again, I have a distance of 1 from the x-axis. 1 times 3 is 3, so now I move up 1, 2, 3 units. This point has a distance of 2 units from the x-axis, so I move 2 times 3, or 6 units up. 2, 3, 4, 5, 6. And this point's 3 units away. 3 times 3 is 9, so that vertically stretches up to 9 units away. If you're struggling with dilations, it's okay. Tomorrow night's lesson is all about dilations, and the lab we do in class is all about dilations. So we really focus on them for an entire day. And so don't worry if that's the hard part for you. It's always the hardest part of this chapter, and you'll get it after we practice it lots and lots. I built in an extra day on purpose. Okay, so that's playing with our parent square root graphs. And now I ask you to do similar things to your parent x cubed graphs. And again, math is consistent, and I know that some of you find that obnoxious because I say it all the time, but I say it all the time and make it obnoxious because it's true, and the sooner you believe it and trust it and hear it, the better off you'll be, and the easier math will be for you. And here's what I mean, and it's going to make me move a little faster as well so that you can see that that works. Here again in my k place, I have a -7. Any number outside of a parent graph, added or subtraction, is a vertical translation, up or down. In this case, I move down 7. So I take all my points on my parent graph, starting with my anchor, and move them down 7 units. So my new anchor point is 0, -7. From there, the shape stays the same. From my anchor point on my parent, I go over 1, up 1, over 2, up 8. Same from this anchor. Over 1, up 1, over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And the same is true on the other side. Over 1, down 1, over 2, down 8. I can't quite get there, so just show what you're meaning to do. For number 6, we have a -7 within parentheses. Again, this is a -7 because this is x minus a +7. So a -7 in parentheses means move your parent graph to the right 7 units, to the +7 on your x-axis. So I'm going to move my anchor to 7 on my x-axis and land at 7, 0. And from there, the shape stays the same. Over 1, up 1, over 2, up 8, left 1, down 1, left 2, down 8. And I know I'm doing this quickly, and I'm doing this quickly on purpose because you should get to the point where you're this quick as well. If you know your parent graphs, and if you know the really 4 basic transformation rules, vertical translations, horizontal translations, line reflections, and dilations, and remember that math is consistent, then you will be graphing this quickly before you know it, if you're not already. Negative x cubed. Negative a is a reflection over the x-axis. So you take your points and you go the opposite direction over the x-axis. Your anchor point doesn't change with a line reflection. And look how quickly we can start to graph these because we know parent graphs and we know basic transformation rules. And that's really the point. That's why we take your inspires away. I don't need it. I'm not even looking at it. I just know some rules and some parent graphs. Okay. Number 8, 1/4 x cubed. That's a dilation of 1/4, which, since it's a fraction, I need a wider graph. So it's a vertical shrink back toward the x-axis by a factor of 1/4. So I take my distances from the x-axis and I multiply them by 1/4. 0 times 1/4 stays 0. 1 times 1/4 is 1/4. Both sides. This distance of 8 times 1/4 is 2. And there we're already seeing our wider x cubed parent. And that's all I need you to do. I think that's it for tonight. It is. Tomorrow, again, is dilations. So, weekend homework. Practice, practice, practice. Study your parent graphs. There will be a pop quiz on Monday. I can promise you that, with bonus. So know the 4 basic parent graphs that we focus on, but also don't forget about the others that we talked about, the reciprocal graph and the 2 to the x, the exponential graph. Don't forget your definitions either. We have new words, hyperbola, asymptote, things like that. All right, have a great weekend. I hope this is getting better for you. I won't see you Monday in class. Remember, I'm at a 100th birthday party for my grandmother-in-law, so I'll see you Tuesday. Work, 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 study. Have a good day. See you Tuesday.